Hello, ladies and gentlemen. We are at the point now where we're going to try to finish up this assignment and finish up this spreadsheet. Last class, we figured out what the standard deviation is and how far we get away from the mean for a standard deviation. Now, what does standard deviation mean? Let's talk about that a little bit. So standard deviation is kind of a way in statistics for us to look at what is a normal amount to be away from the mean. And we'll talk about the empirical rule in a few minutes. So the way I like to think about this is you're in the mall and you're walking around the Roosevelt Galleria Mall, let's say, and you are just walking around with some friends, and you don't notice the height of most people, right? Because most people are within one standard deviation of the mean. They're pretty typically towards the middle, 5, 7, and 8-ish of height, right? Now, you might every once in a while notice somebody walking by that's significantly short or tall. Maybe you didn't notice them from a ways away, but now you notice them as they walk by. That person's probably more like 2 standard deviations of the mean. They get a little bit farther away from the average. And then there's the MBA center, right? The super tall person that you see all the way down by Nordstrom's when you're standing like by Macy's. I don't go to the mall, so I'm assuming that's a ways away, right? So that person would be more like 3 standard deviations away from the mean. In teaching this very lesson to adults during the summer, I had a student who was 6'8", and I started to ask him, and he knew exactly where I was going, and he said, I'm 3 standard deviations away from the mean, because he happened to teach statistics also. So that's the way to kind of look at this, and we'll talk about the empirical rule in just a moment. Now, what we're going to do is make a histogram of this information. So the first thing to do before we even make the histogram and make the chart is highlight your data. It will help the spreadsheet know what you want. So we know we want to make a chart out of this data. So I just highlighted it all by dragging my mouse. And now I am going to insert a chart. You can either say I want to insert a chart, or you can just come over here to this little icon and say insert chart. Now, the computer or this whatever defaults in the spreadsheet thinks maybe you want a line graph. Well, that's not what I want. So what you have to do first is go over here to chart type, get the little drop down menu, and you're going to scroll down until you see this one, the histogram chart. If you hover over it, you can click on that and it's going to produce a histogram. Now, this can be moved around. We can change things in it. We're going to change some labels and stuff like that. You can come in, you can change the color of your thing. You can put background colors, all of that stuff if you want, but you don't have to. So this is a visual representation of our data from -10 degrees all the way up to 35 degrees. It created bins for me. Now, right now there are 5. Personally, I like between 7 and 11 bins, tends to work very well. So first thing we're going to do is we're going to edit that by over here and customize. We're going to go to histogram, and right now these are called buckets, right? It's as if how many of these go in each bucket, and right now it's on auto. So click that guy, and right now it's on 10 because it's going for, or I guess it's on 9 right now. Let's try 5 and see what happens. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I like that. Now your data might be a little bit different. You're going to have to play around with it a little bit. You might have to type in a number. Make it a whole number. Don't make it something weird like 3.27131. That, make it clean. And get yours somewhere between 7 and 9 bins. So again, what I did is it was on auto, which made my bins, each one is 9 degrees worth. So in other words, there are 4 times that the temperature was between -10 and -1. There was 10 times that it was between -1 and 8, and so on and so forth. So you're going to choose that bucket size and go down and just start clicking. You could type in, maybe I want 6 and see what happens. Okay. And actually 6 does really well. 1, 2, 3, 4, 5, 6, 7, 8. The only thing is I like an odd number of bins instead of an even number, because then it gives me hopefully the mean right in the middle. So do make it an odd number. Whoa, that's weird that it changes that much. Let me try that again. Wow. So it's funny how much it changes in terms of what the values look like between 6 bins and 5 bins. Huh. Okay. It kind of changed the height of them. So I think I might try that again. Let's edit. You can always go back and edit the chart, customize. I think I am going to go back to that 6, even though I tend to it gives me a better visual of what we're looking at, that temperatures tended to be on the colder side of average than on the warmer side of average. All right, so we have our histogram chart. Next thing we're going to do is we're going to take a look at how many times each thing's happened, and we're going to change our values. So first of all, I don't really need a chart title, so I think I can get rid of my chart title. I wonder if I just hit backspace in there. Yeah, let's just do that. There, that got rid of the chart title, because I know it's a histogram. It's okay. Now I'm going to put in, I can double click on this where it says data value XI. And we're going to put, instead of that, I am going to change that to frequency, the number of times that occurred. Okay, so it says frequency. Now I'm going to need to add an x-axis. So again, I'm going to have to come back here, edit chart, customize. I'm going to go to the horizontal axis. Okay, and it says, what do I want in here? I think what I want is labels. Hang on, I need to look at where to find this. Okay, I know where, whoops, I know where I was. I need to edit chart again. And I should have stayed where I was with the chart and axis titles, because I changed the vertical axis title to frequency, and now I need to change the horizontal axis title and create that, and we're going to call that temperature in Fahrenheit. I think I'm going to spell it right. Might need to look it up. And I did misspell it. Oh, there's an H in there. Okay. All right. Cool. So we've got frequency, temperature in Fahrenheit, and there is our histogram. Please grab that by holding on the mouse and drag it over so it's just to the right of your data over here. All right. Now, what we're going to do is we're going to find out if our data is normal or not. And first, we're going to have to identify where our mean is, where our standard deviations are, and so on and so forth. So here we go with that. Please go to insert up here, and we're going to insert a drawing. Unfortunately, there's not tools in Google Sheets to just draw lines on, so we have to create a drawing, which brings you up to this. Now, what we're going to do is we're going to do this several times. We're going to insert an arrow, draw an arrow. Whoops, I meant to make it going the other way. Oh, hold on. Undo. Let me flip that around like this. There we go. So you can make the arrow whatever color you want. I think I'll make things red. Probably ought to make it a little bit thicker. Ooh, that's too thick. Let's try maybe 3-point. That'll work. So we're going to make an arrow, and we're also going to make a text box. And the text box is going to say mean. There may be a way of putting in that little symbol, but I'm not going to do that now. I'm going to make that bold and red also. I might have to stretch it out a little bit. And I'm going to connect that or put it up there near my arrow. All right, so it looks like this. And we're going to save and close, and that will insert this into my drawing. Now I can take this and move it around. Now you have a different data set than I do, so you have to think about where is the mean. You know what? I'm going to edit that before I move on and make my arrow a little shorter. There we go. So make it look about like that. All right. Now, for me, the mean is 10.35. So if 8 is here, and we start putting things in at 8 degrees, and then 14 degrees is over here, then the middle is 11-ish, right? 3 and 3, right? So 10.35 would be somewhere about here-ish. So you're estimating, and that's okay. We're going to estimate where that is. Okay, so we're putting the mean up here. All right, guys, I'm not going to remake this video, but I'm going to change that again, edit, and I'm going to change it back to a longer arrow because I don't want it. There we go. Whoa, and I want it straight. It's going to annoy me if it's not straight. So there we go. Okay, so that's kind of the way that I'd like this to be. I'm going to move myself up here somewhere. All right. So we're going to now, I think I can copy this. Let's find out if I can copy this drawing. Doesn't look like it, so I'm going to have to make a new one. So I want to identify where the mean is. I want to identify where the mean plus 1 standard deviation is. So I'm going to insert, drawing, do the arrow thing again. If you can figure out a way of copying it and editing it, then that might even be better. Oops, let's go upward this time. There we go. Makes me crazy that I can't just make these things straight because I want it to be nice and straight. All right, try and make it the same as I did last time. Text the same as I did last time. This is now the mean plus 1. Actually, I'm going to hit enter and go downward. The mean, so I can keep it a little more compact, mean plus 1 standard deviation. I'll just put SD is close enough. And again, I like it bold. We're going to make it red. This is going to be under the arrow, about like that. Okay, so in save and close, can insert that in, and I'm going to find for me the mean plus 1 standard deviation, which is at 19.44, which is going to be just in front of that 20 right about there for me. And again, everybody's going to have different values. So I really wish there was a way of copying that so that I could just reuse it. Oh well. So I am now going to do the same thing with the mean plus 2 standard deviations and the mean plus 3 standard deviations. Now, if it's off the chart, put it where you estimate it's off the chart, okay? And you're going to do that. So you're going to do that a total of mean. So you'll have 7 total things on this chart. Go. And that took me a little time. It'll take you some time too. And I realized that I put my mean, I was thinking 11, and then I went on the upper side instead of the lower side. So I actually moved that a little bit. And when you're done, they should be fairly evenly spaced, right? Because it makes sense. It's a linear progression. And if we take a look at this, there are no values that are beyond three away from the mean, 3 standard deviations away from the mean. There is maybe 1 or 2, not sure how that works out, that are more than 2 standard deviations away from the mean. So we're about to find out if this meets the empirical rule. So here we go with the next step. What we're going to do is we're going to highlight everything that's within 1 standard deviation of the mean. So here is how to do that. What we're going to do is we're going to highlight our data set again. Okay, and up here in your toolbar, you have format, I believe. Yes, click on format and then click on conditional formatting. All right, right now it's saying to do something if the cell is not empty, which means it's making it that color. But what we're going to do is we're going to format the cells if it is between, I got to move myself out of the way again here, and we're going to put is between. Okay, so we're going to put that in there. Now, I don't think you can just click on the value. So we're going to say if it's between +1 standard deviation and -1 standard deviation. Let's see if I can do that and click on that. Click in there. Or if I can click on equals and that. No. So I'm going to have to copy it, and that's okay. I'm going to copy this number. Probably would have been just as easy to type it in. If it's between that number, and I'm just going to type in the other one. Let's see, which was the mean -1, which is negative. Oops, I shouldn't have the equals in there. Let's get rid of that. And negative 1.26, 1.26, oops, 209. So again, you're going to put conditional formatting, conditional formatting. We are choosing if cells you're choosing is between, and you're putting whatever value you had for the mean -1 for one of them, and the mean minus or +1 standard deviation for the other. Now you can choose whatever color you want, and you're going to choose that. Done. Now it's highlighting all of our data that is within 1 standard deviation of the mean. Now we're going to highlight everything that's within 2 standard deviations of the mean. It's going to get a little tricky here. So we're going to add another rule, but first we're going to highlight our data set again, the whole thing. We're going to add another rule, okay? And we're now going to do the same thing again. We're going to format cells if is between, and this time we're going to do 2 standard deviations away from the mean. We're not going to do 3. So we're going to do, this time I'll do negative. So -2 is negative for me. Again, yours are different. You got to look at your chart to see what the mean -2 is. And whatever the mean +2 is. Okay, now we're going to make it a different color and say done. Okay, and now because this one was done first, it's going to show what's up there and what's not. And that means that we do have 2 that are more than 3 standard deviations away from the mean. Okay, now let's talk about what the empirical rule means, and we're going to see if this set of data follows the empirical rule. So let's talk about that for a moment. The empirical rule applies to what we call a normal distribution, meaning our data is normal. If you've ever heard of an empirical study, it means that their data, it follows kind of this rule. It's not all weird, okay? So here's some example of your bell curves that we've been talking about, right? For how your data is spread out. So these are all fairly normal looking curves. The difference between these would be, I'm not sure why this green one is down over here, not close to zero. Maybe the average is somewhere around -2. But let's look at these three. So this curve that's tight would be more like the diameter of a heart valve, an artificial heart valve, right? It's got to be very, very, very precise. So the deviation from that average is going to be very, very little. It's going to be really tight tolerances, right? Whereas if you measured, an 8x10 shed and you measured the length of it, well, some of them might be a quarter of an inch more, a quarter of an inch less, maybe even a half an inch off. So those values are going to spread out a lot more, but it's still going to be close to the average. Okay, so that's what that means. So here's the important part that you need to understand. If the data is normally distributed, okay, that means that around 68% of the observations or the data should fall within one standard deviation of the mean, as represented by the red in this bell curve. 95% of this observations fall within 2 standard deviations of the mean. So that means all of the data that includes the red and the green, and 99.7, almost all of it will fall within 3 standard deviations of the mean. So remember when I talked about like seeing the MBA Center way down at the other end of the mall? That's because they're part of that 0.3% of people that are that tall, right? So so those get way out of the norm. So in our field in engineering, if we were designing, connector pieces that were part of trusses on a bridge, and one of them was more than 3 standard deviations off, we might want to reject that or find out why that's happening in the manufacturing process. All right, so that is what that looks like. Here's another example of what this would look like in a normal distribution. 68% falls within, so if these dots represent pieces of data, falls within 1 standard deviation, 95% within 2 standard deviations mean, and then for this data set, there's that one little guy. All right, it is your turn. And this is the last thing we're going to do on this spreadsheet is we're going to say, come down here to somewhere in an open area where it's still visible in your spreadsheet, but maybe down here-ish, okay, to an open spot. And we're going to type in percent of data within 1 SD standard deviation of mean, colon, which means we're going to put that there, and then click somewhere else and it will show up. Now it was going, I want that, why is that not, I want that to be going the other way. So I'm going to turn my text wrapping to, maybe I need to go the other direction. That is not what I meant to do. I was hoping that would go to the right. That's what almost always happens. Hold on, I need to fix this. Bizarre. Okay, I'm going to see what I did wrong in case this happens to you. I don't know what is happening here because normally this would go and to the right, not to the left. So I'm going to just take that and cut what's in there and paste it maybe over here. And I'll just start on that. That's just so weird. So I'm going to copy this, what's in that cell, and paste it there. Now I'm going to edit this. remember, I have to double click where it is, and I'm going to edit that to say within 2 standard deviations of the mean. All right, now here is how to figure that out. You need to figure out how many pieces of data there are divided by the whole number of pieces of data. So I have 30 pieces of data. Oops, I think I said that there were 30 pieces of data. I had 31 days in January. So if I look at what's within 1 standard deviation of the mean, that would be 29 minus these 6 rows, right? And I include the 7. So that gives me 23 values. So here's how you're going to put the percent in. In parentheses, you're going to say, or sorry, I want to start with an equals because I'm going to do some math here. And in parentheses, because I want to do order of operations, I want to say that this is the 23 values that are within 1 standard deviation. Again, yours are going to be different, right? I don't know how many you have within 1 standard deviation of the mean. Count them. Divided by the total number of values you have. You will either have 28 if it happens to be February, 29 if it happens to be February on a leap year, 30 if it's one of the months with 30, or 31 if it's one of the months with 31. So it's, for me, it's 31. And then in parentheses, and we're going to multiply that times 100. That will give us a percentage. So it's my number of values divided by the whole number of values that there are in parentheses times 100 will get me a percentage. So it's 74% within 1 standard deviation of the mean. Now within 2, it is 29 out of 31. So we're going to do the same thing here. Again, you're going to have different data. For me, it is 29 divided by 31 times 100, which is 93. Now, let's remember what our empirical rule said. It said that 68% would be within 1, 95% would be within 2, and then pretty much all of it for this small of a data set will be within 3. Before I decide, I'm going to take these 2 values and just lower the number of decimal places to 1, because that's close enough. And now, somewhere over here next to this, I want you to say one thing, yes or no. Do you think your data is normal? Now, you have to make a judgment call because it's not going to be exactly 68% and exactly 95%. Okay, mine is a little less here, a little more where it's 74 instead of 68, but that actually compacts it closer. So my answer is going to be yes. Yours might be yes, and it might be no. It's going to be a judgment call. So you're just going to put one word, yes or no. I will not even judge you as to whether or not I think you're right. I just want you to think about it and give me an answer. All right, ladies and gentlemen, this is what you are going to take a picture of. Make sure that everything's there. If you need to, you can come up to your window. Like right now, I'm at 90% and zoom out if you must, okay, or wherever you need to be able to capture all of this spreadsheet and get a picture of it and put it into your assignment. Actually, I may not have you take a picture. It depends on look at what the assignment says. If it says take a picture of it, do it. If not, I'll go look at it. So, all right, folks, congratulations. You have finished with the statistics stuff for now. Might be one other thing to do. All right, see you next time.